The Getting Started with Policies video tutorial. Some people try to configure firewall policies without really understanding what to do or how to set them up. And then, if the policies don't operate as expected, people tend to blame the firewall. Creating a firewall policy should not be a matter of trial and error. In this video, I'll review the information and knowledge you need to get your Firebox or XTM device policies right the first time. The primary reason to create firewall policies is to identify what connectivity is allowed through your firewall. The network you have invested in is vital to your business, and ultimately, you want to control what kind of traffic goes across your network, where it comes from, and who's using it. Another reason to create policies is if you want to translate your company's computer use policies into firewall policies. For example, does your company allow employees to access social media sites, block social media sites completely, or selectively grant access to social media sites to certain users based on job roles? No matter how you answer these questions, setting up firewall policies can help you achieve your company's goals. In order to understand how to create policies, understand the three security zones of your device, which are the external, trusted, and optional interfaces. An external interface is used to connect your device to a network outside your organization. Often, an external interface is the method used to connect your device to the internet through your ISP. And you can have more than one external interface if you need. A trusted interface connects to your company's private LAN or internal network. Just like with the external interface, you can have multiple trusted interfaces, which can help you set up per-department policies. For example, you might set up a trusted interface for your HR network, one for your executive network, another for your IT staff, and so on. Optional interfaces are often used as mixed trust or DMZ environments that are separate from your trusted network, and you may or may not choose to use them. Resources typically found on an optional interface include public web servers, email servers, and FTP servers, all of which you want to protect. The name of each interface also acts as an alias you can use to define your firewall policies, including, for example, any trusted, an alias for all networks behind the trusted interface. Before you create any policies, you need to have a basic understanding of Cs. You need to work address translation. NAT is a feature that lets you stretch the number of computers able to work off of a publicly routable IP address, and to hide the private IP addresses of hosts on your LAN. There are three types of NAT: static, dynamic, and one-to-one. With static NAT, which is sometimes called port forwarding, you can bind an external address for each public IP address to the private IP address of the server hosting it, located on your trusted or optional networks. Simply put, static NAT is useful for inbound connections, giving the public access to public servers protected by your firewall. Dynamic NAT, also known as IP masquerading, is the most frequently used type of NAT. Because by default, the firewall's dynamic NAT rules change the private source IP address of any outgoing connection to the public IP address of the external interface, you might not even realize dynamic NAT is occurring. Dynamic NAT ensures that the responses to your users' outgoing connections return to where they originated on your network. Dynamic NAT is perfect for outbound connections initiated by client computers protected by your firewall. But it won't help you when you want to make servers available for inbound connections from any internet user. The combination of dynamic NAT and static NAT is powerful and allows you to translate both inbound and outbound connections. If you want to avoid creating a separate rule for inbound and outbound connections, you can use a third type of NAT, one-to-one NAT, to create a mapping between public and private IP addresses. One-to-one NAT translates outbound connections from private IP addresses to public IP addresses, and inbound connections from public IP addresses to private IP addresses. One-to-one NAT is not frequently used because it creates an exclusive link between a single public IP address and a private IP address, which may not be very useful unless you have several public IP addresses to spare. I'll show you how to create a new policy in a moment. Let's review a checklist of the things you need to know in order to make sure your policies work as expected. The first thing you need to know is what you want the rule to do. Is it going to allow or deny certain packets in your network? When you configure your device, the default stance is to deny connections that have not been explicitly allowed. You might want to add an explicit deny if, for example, you want to deny connections some of the time or for some of the people, but not all of the time for all of the people. Then you can add a policy for those connections and set the disposition to deny. Next, you need to know which protocol and port you want to control. When I do the demo for you, you'll notice that WatchGuard has a lot of predefined policies that you can choose from for common services. But if you don't see what you're looking for, you can create a custom policy. The next thing you need to know is the source. Where's the connection coming from? This could be an alias, a user, a group of users, an IP address, a subnet, or a host range. The destination is the other end of the connection you're trying to control. When you configure a policy to control traffic between a source and a destination, it's important to understand that the policy handles both the request and the response. For example, a policy that allows a connection from a client on your network to an external web server also allows the response to that connection. You don't need to create a separate policy for that return response. If you're using static NAT or the firewall server load balancing capabilities, you'll be able to configure that with the destination. Your device uses two categories of policies to filter network traffic: packet filters and proxies. A packet filter examines each packet's IP and TCP UDP header. If the packet header information is legitimate, then the device allows the packet. Otherwise, the device drops the packet. A proxy examines both the header information and the content of each packet to make sure that the connections are secure. This is also called deep packet inspection. If the packet header information is legitimate and the content of the packet is not considered to be a threat, then the device allows the packet. Otherwise, it drops the packet. Proxy policies are available as an option for TCP, SMTP, POP3, HTTP, HTTPS, and FTP connections. You can use policies to enforce a schedule. For example, you can configure a particular policy to be operational only during business hours or only after business hours. If you have multiple wide area network connections or multiple connections to the internet, you can use policy-based routing. For example, browsing goes to ISP1, VPN traffic goes to ISP2, and so on. While policies use dynamic and one-to-one NAT rules by default, you can disable the default rules per policy or choose to apply dynamic NAT to all traffic in the policy and even specify a source IP address. You can define source IP addresses per policy to use when dynamic NAT is configured in the policy. Each policy contains configuration options to enable traffic management and quality of service. These are considered more advanced policy options that won't be discussed in this video. Now that you know the components of a policy, let's your configuration by default when you set up your device. The WatchGuard policy controls management connection. By default, the WatchGuard policy is set to allow traffic from any trusted or optional network to the device itself. If you use multi-WAN, your policy-based routing configuration settings would show here. But because I only have one external interface configured, these settings aren't visible right now. There's one important part of a policy we haven't talked about yet, and that's logging. After you set up a policy, it is important to verify that your policy